Welcome to Recording 1C in our series involving adding and subtracting rational expressions for Unit 6, Chapter 6, Mathematics 2200. Now, even though we are talking about adding and subtracting rational expressions still, we also will bring in some work from multiplying and dividing rational expressions so that we'll have to use the order of operations. Example 1. So we've got two different operations between our rational expressions. You may recall the acronym BEDMAS. Perform operations in brackets first, then take care of exponents, then division and multiplication in the order they occur, then addition and subtraction. So we don't have to worry about any brackets or exponents in this case. We do have to worry about whether there's any division or multiplication. We got a division right here. So that's got to be taken care of before any subtraction. So when we divide, we're going to have to multiply by the reciprocal, but we should factor everything first so that we can get our non-permissible values we need. So we have n minus 1 over n minus 2 here, divided by n minus 1 again, or n minus 1 squared, if we want to write it that way. We have n outside of n minus 2. So our non-permissible values, I'll abbreviate that so far, are we have n equals 0, n equals 2, n equals 0 again, and another n equals 2. Now when we divide, we have to multiply, or one way to do it, I guess, is to multiply by the reciprocal. The reciprocal of the divisor. So we have n outside of n minus 2 over n minus 1, n minus 1. So that gives us more non-permissible values. So that's the one we get after taking the reciprocal. Now, we'd like to simplify here. We have an n minus 2 divides into n minus 2 because remember when we have multiplication, it's the same as if we just extended that full fraction line. This n minus 1 can divide with one of these n minus 1s, and we are left with n plus 1 over n minus n over n minus 1. Now we need to get the LCD. The LCD consists of n and n minus 1. So our first rational expression needs an n minus 1 to get that LCD. So we multiply the top and the bottom by n minus 1. The second rational expression needs an n. So I will multiply by n in the top and the bottom. So expanding the top of this one, n plus 1 times n minus 1 is n squared minus 1 over n outside of n minus 1 minus n squared over n outside of n minus 1. The n squared subtract n squared, they're going to be gone. So we're left with negative 1 over n outside of n minus 1. Writing our restrictions, n cannot be 0, 1, or 2. Now this next one looks a little unusual. We have fractions within a fraction. It's called a complex fraction. There are at least 3 different ways to simplify complex fractions. I will demonstrate what I think is one of the quickest ways, one of the 2 quickest ways. If this is not a method used in your class, you should check with your teacher. So I'll begin by factoring all denominators. Factor all denominators. So in this case, I have 1 over x plus 4, nothing I can do with that. 1 over x minus 4, all over x minus 4, x plus 4, plus 1 over x plus 4. Next, we find the lowest common denominator of all the rational expressions, not just a particular pair, but all 4 in this case. So we have x plus 4, x minus 4 is the LCD. So next we multiply the numerator and denominator of the complex fraction by the LCD, like so. So now we distribute this LCD to both terms in the brackets. So x plus 4, x minus 4 times 1 over x plus 4. The x plus 4s would divide, and we would be left simply with x minus 4 times, or just x minus 4. Likewise, when I distribute to this term, the x minus 4s would be gone, and I'd be left with x plus 4. All over. Distribute the LCD to this term, x minus 4 and x plus 4 are both gone, I'm just left with x. And distribute to this final term here, the x plus 4s would divide, and I'd be left with just x minus 4. So in the top here, the minus 4 and the plus 4, they would cancel each other out and have x plus x is 2x over 2x minus 4. We do have one little bit of simplification we can do there. We have 2x over 2 outside of x minus 2. So the 2 can divide into this 2 to get 1. We are left with x over x minus 2. And one thing we didn't do was find the non-permissible value. The non-permissible values are found back here. We have negative 4. There, I've adjusted that arrow to get it out of the way. Negative 4 and 4. And we have another one right here at x equals 2. So we have x cannot be negative 4, 4, or 2. So in summary, when performing multiple operations on rational expressions, be sure to follow the order of operations.